Join me in measuring SMD-type inductors and analyzing their magnetic saturation current and temperature rise current characteristics. Step 1. Please install the SMD test fixture onto the instrument. Use the handle tool to loosen the nuts, then install the SMD test fixture onto the instrument. Before measurement, you must perform the correct calibration. During the open circuit calibration, please place the open circuit plate to execute the open calibration. First, loosen the nut at the back of the fixture, then lift the fixture's probes upward. After placing the open circuit plate, press the probes down, and simultaneously tighten the nut at the back of the fixture. Adjust the nut on top of the SMD test fixture to the appropriate level from a different angle. After placing the open circuit plate, if you notice that the probes are not touching the open circuit plate, you can adjust the nut at the back of the SMD fixture to make the necessary alignment. Set the measurement parameters, measurement frequency, and measurement voltage. Press the correction key on the 6632 to enter the calibration menu. Select Open to perform the open calibration. Then place the shorting plate and perform the short calibration. When the probe does not press down on the shorting plate, first loosen the nut at the back of the fixture to adjust its height. Then lower the probe onto the shorting plate, and once it makes contact, tighten the nut at the back of the fixture. Adjust the nut on top of the SMD test fixture to the appropriate level from a different angle. If the probe does not touch the shorting plate, loosen the nut, press the probe down to the shorting plate, and then tighten the nut. Press the correction key on the 6632, select Short, and perform the short calibration. Place a 100 ohm resistor onto the SMD test fixture and perform the high-frequency load calibration. press the correction key on the 6632, select HF load, and execute the high-frequency load calibration. Return to meter mode and select the Rs parameter to confirm that the high-frequency load calibration has been completed correctly. After completing the correct calibration, we can start measuring the inductance. You can select the list mode function to edit multiple parameters you want to measure. Once the settings are complete, the instrument will display the measurement results for all the parameters at once. Press the menu button on the 6632. Select List Set to enter the list mode editing screen, and input multiple measurement conditions. After completing the parameter settings, select List Run to enter the multiple test conditions you have edited. Once confirmed, press the trigger button to execute the test. Apply a DC bias current of 35 ampere to the inductance and measure the extent to which the inductance value decreases. This will allow you to plot the ESOT, saturation current, curve. Press the menu button on the 6632, select ESOT, and enter sweep mode. Set the DC bias current, frequency, and voltage. The instrument will apply the DC bias current and measure the inductance's magnetic saturation current characteristics. The measurement result will be the ESOT curve. Visually inspect the percentage decrease in inductance. This system supports thermal current characteristic analysis, generating thermal current curves. The inductance temperature rise analysis is based on the temperature coefficient of copper, using internal resistance measurement technology for more objective and precise results. It is important to note that if the inductance has a very low DC resistance, this measurement method is not recommended for analyzing the temperature rise current characteristics. Press the 6632 menu button, select Temp, and enter sweep mode. Set the DC bias current, output duration, alarm temperature, and stop temperature for current output. Press the 6632 trigger button to output DC bias current and measure the inductance temperature rise current characteristics. We can use sweep mode to obtain high-frequency characteristic curve analysis of the inductor. Press the 6632 menu key and select Sweep to enter sweep mode. You can scan up to 2 curves, trace A and trace B, simultaneously to analyze the high-frequency performance of the inductor. Finally, we can capture the measurement results through the USB host. Insert the USB into the 6632's USB host interface. The instrument will display a menu. Select Save Screen to capture the test screen and save it to the USB.